So example number 3. The T section shown in the figure is a cross-section of a beam forced by joining two rectangular pieces of wood together. The beam is subjected to a maximum shear force of 60 kilonewtons, meaning we don't have to draw the shear and moment diagram because first we don't have the longitudinal section of the beam and the loading, but second gitaga na ta og shear force maximum. So it's the Vmax. And show that the neutral axis is 34 millimeters from the top, and the moment of inertia is 10.57 times 10 to the 6th to the 4th. Okay. So first is, let us consider this one as our first area. So I'll call this as area 1. So this is our area 1. And then I'll call this as area 2. Okay, so right, so we're going to place a reference line. So I'll call this reference line, the X reference line. Pagkahuman, I'll be measuring the centroid of this area 1. So it's found here. Dire lang ta sa pikas. It's found here. Muralig siya hiwi. And this is Y1. And then here for the second area, this is Y2. Alright, so that's all for area 1, area 2, Y1, and Y2. Because we will be proving that it's 34 from the top fiber. So we're going to actually get the neutral axis. Ibutan lang sa nato ang horizontal line. Maybe I'll set the neutral axis here. So I'll just place here the neutral axis location, maybe. And therefore, this is the barred Y. So therefore, the location of the neutral axis DI is ato iswateri. So the location, so the location of the neutral axis is actually the addition of 40 and 100, which is 140. 140 minus barred Y. And we're expecting that to be 34 millimeters. So is it 34 millimeters? So ato nang i-prove. So first is, in order for us to be able to get the barred Y, we need a Varignon's theorem. The total area times barred Y is equal to area 1 times Y1 plus area 2 times Y2. Of course, we're adding the two sections. And area 1 is the product of 40 times 200. So this is 8,000. Square millimeter. And then our barred Y. So what is the distance of our barred Y? It's basically 1/2 of kanisha. This is 1/2 of 40 and 100. No? So gi-add na to ang 1/2 of 40 and 200. I mean 100. So 100 plus 1/2 of 40. This is 120. And then our area 2, it's 220 times 100. So this is 2,000. And then y2 is 1/2 of 100. 1/2 of 100, and that's 50. So let us get the area total. It's actually area 1 plus area 2. So the area total is 10,000. Okay, let's rewrite. So that's 10,000 times barred Y equal to 8,000 as Y1 times 120 as, no, 8,000 as area 1 times 120 as the Y1, then plus 2,000 times 50. So our barred Y, pila atong barred Y atong kumpiton, 8,000 times 120 plus 2,000 times 50 divided by 10,000. It's 106 millimeters. So is this going to satisfy that it's 140 minus 106 equal to 34? So atong na-prove nga it's correct. Location of the neutral axis from the top fiber, no? So mo ni ang gipangita actually kani nga distance. This is 34 there. And let us proceed in getting the moment of inertia. Ningon ba siya? Show that the neutral axis is 34 and the moment of inertia is 10. Okay, let's show the moment of inertia. Okay. Moment of inertia. So moment of inertia is equal to I1 plus I2. And I1 is equal to the centroidal moment of inertia plus area 1 times d1 squared. So d1, it's actually the difference between y1 and barred y, and you get the absolute value, no? So pila man na siya. Y1 is 120, barred y is 106. So d1 is 14. Sakto. Y1 is 120. And then I1 now, it's centroidal moment of inertia. It's BH cubed. So the base of area 1 is 200. So it's 200 times the height, 40 cubed over 12. Then plus the area is 8,000 for the area 1 times d1 nga 14. And do not forget to square it. So this is our I1. That's 200 times 40 cubed over 12 plus 8,000 times 14 square. It's 2.635. 2.635, and that is times 10 to the 6th mm to the 4th. Next, let us solve for I2, and that is centroidal axis, centroidal moment of inertia times area 2, d2 square. And then, of course, d2 is the difference between barred y and y2. If negative ang value, get the absolute value. So it's 106 minus 50. So this is 56 as D2. Alright, so our I2 now, it's base. What is the base? The base of the second area is 20. So that's 20 times the height of 100 cube divided by 12 plus area nga 2,000 times 56 square. So we need a value, maybe mga 7 roughly. So that's 20 times 100 cube over 12 plus 2,000 times 56 square. Yes, so that's 7.939 times 10 to the 6th mm to the 4th power. So therefore, our I is I1 plus I2. So we're gonna basically add this and this one. So ato na lang i-add. That's 2.635 times 10 to the 6 plus 7.939 times 10 to the 6. So that's 10.57. Oops. That's 10.574 times 10 to the 6th mm to the 4th. So this is our moment of inertia. And we have proven that we're correct. And that one. So, okay, na tayo moment of inertia and I mean the neutral axis location. Let us now continue. What is the compute the horizontal shearing stress at the neutral axis? Okay. So pila daw ato ang shearing stress at the neutral axis. Can I erase this? Ano? Maghimo na lang kog bag-o. Okay. And then we have this one. I'll just place the neutral axis location. Okay, so that is the location of the neutral axis. And then of course, if we try to draw the stress diagram, it's gonna be like this one. Since this is the neutral axis, the stress would be like this. Something like that. And here. So, nadiri ang pinaka... No. Dili dita maka-assume ani ngayon ani because this is a composite section. So, lain-lain siya o material. I mean, gi-connect sila ng material. Dili siya monolithic. Kanang kausa na himo. But, gi-join together siya. So, we're going to check kung asa dapita ang dako nga stress. But, for the meantime, we're asked to find the stress here at the neutral axis. So basically, you end up with two areas nga imong i-consider. Kaya nga na nagisgutag area tungod ani. Stress, shear stress is VQ over IB. And then Q is about area times barred Y. This barred Y is not the 106 that we got. This barred wire is the area, the location of the centroid of the area nga atong i-consider. So, I hope ma-clarify na siya. Actually, the area nga ato i-consider kay you have two choices. And I'm gonna let you choose kung asa ang better. So, the area is bounded with moment neutral axis location. So this is the first area to be considered if ganahan ka ani. But if dili ka ganahan, then we have a different area. Here. Hindi ka ganahan na ito lang area. This one. Hantod na siya diri. And here. So actually, it's really simple to, or it's really easy to judge kung asang area atong i-consider. So basically, this is the area that we will be considering. Here. So kana siya nga area. Kani nga area bounded by this line. No? So that's the area nga atong i-consider. So pila man na siya nga area. Remember that distance is not 40 but that is 36. 34. So the area di it's going to be 200 as the base and the height as 34. That's the area. So 200 times 34, it's 6,800. And then our barred y is the distance from the neutral axis of the area kana padung sa kana. So the distance of the centroid of the area padung sa neutral axis. So this is basically 1/2 of 34. So barred y is 1/2 of 34. And this is 17. Therefore, our Q, it's the product of 6,800 times 34. So that's 115. 115. 600. So 115 600. Sakto ba? And yeah, 115 600, and the unit is in cube. And then our V, of course, do not forget, according to problem, that the V is 60 kilonewtons. So it's 60 kilonewtons or 60,000 newtons. Then what is the base that we will be using? Since ang gipangita nga stress is at the neutral axis, so this is the base nga niagi sa neutral axis. And that's 200 mm. Right. Then I nato it's 10.57 times 10 to the 6. Okay, so our stress is equal to, this is 60,000 newtons times the Q of 115 600 mm cube over 10.57 times 10 to the 6th mm to the 4th times the base of 200 mm. So the stress is 60,000 times 115,600 divided by 10.57 times 10 to the 6 times 200. The answer is 3.281 megapascal. So that's for letter A. How about for letter B? Ningon siya nga at the junction between the two pieces of wood. So pangitaw na to ang stress diri dapita at the junction. Alright, so let us consider whenever maghisgot tagingon ani class, there are actually kanang parts nga pwede na to siya ma-name. This one, the vertical one, we call it as web, and then this one here we call it as the flange. No, so let us first consider sa may buhaton na to. Naman ta sa junction, meaning we're torn between two plates or two material. So one is the upper material, then the second one is in the lower material. So basically, it's going to be of different bases. Diba? Base na sa flange o base sa web. So okay, let's consider first the flange. Okay, so for that, since nagisgot naman ta og flange, no, we have here 1, 2, 3, and here, okay, the same gihapon. Stress is VQ over IB. Hindi na sa ni siya masuwat ato na sang tarungon. And atong tarong kadet lang sa. Okay. Okay. We have the same value of V to be 60,000. And then for the amount of koan, the amount of tawag ani, the area, kay magiskot man ta og Q na to, that's actually area times barred Y. So it's going to be, what is this one? Is it 20? Let me just try first. 200 times 40. I know. 20 times 100. And then okay, 20 times 100 times 34, no, 56. Sakto ba? It's going to be 20 times 100. And then okay, to be multiplied by 56. Yes, sakto. Area equal to 20 times 100 times 116 pagkahuman minus 50, so that's 56, diba? Okay, again, since I'm using the area nga kani siya, so therefore the location of this figure padung sa neutral axis, this is 106 minus 50. Okay, this one is barred Y man. This is barred Y. Ano? Na, and then this one here is half of 100, which is 50. Yeah, so 56. And this is not area, but rather a Q. So this is 56. Q is 20 times 100 times 56. It's 112. 1000 mm cube. Cube here. And the base, since nagisgot man tag flange, then it's going to be the horizontal big 200. Kay mo man na ang flange. Then let's substitute. So at the flange, the stress is 60,000 times 112,000 divided by 10.57, the same moment of inertia, times 10 to the 6th, times the base of 200. So the stress here is 60,000 times 112,000 divided by 10.57 times 10 to the 6th times 200. The answer is 3.179 megapascal. So this is the area under, this is the stress for flange. And then let us consider the web. So same gihapon, but this time the base is no longer 200, but ang base sa atong web here, which is 20. Okay, so the stress would still be the same. Shear rather. Still the same, 60,000, and the Q, 112,000 divided by 10.57 times 10 to the 6 times 20. So the shear stress is 60,000 times 112 divided by 10.57 exponent 6 times 20. So dako nga stress ang develop di ay sa web, no, tungod sa kagamyo niya nga suction, tungod sa iyang kagamay, ang iyang dali ra malose ang iyang member or ang iyang bonding here. That's the reason nga nung dako siya stress diha. Okay, so this is our example number